Welcome to Daily Papers, the podcast where we break down the latest and most interesting research into bite-sized pieces.
So, have you ever been in a really long chat with an AI like ChatGPT, and you get the feeling it's starting to lose the plot? Maybe it forgets a key detail from 20 messages ago, or the conversation just starts getting slower and slower.
All the time. It's like its memory is a bit leaky. You have to keep reminding it of things, and that lag is real. When you're deep into a complex discussion, the waiting time for each response can really start to drag.
Exactly. Well, a new paper from Filipek at Reactive AI says this isn't just a feeling, it's a fundamental flaw in how most large language models are built. And it proposes a really clever solution called the Reactive Transformer, or RxT for short.
Okay, a fundamental flaw sounds serious. What's the problem?
The paper argues that current models are stateless. That's the key technical term here, but you can think of it like this. Imagine you're talking to a friend who has no short-term memory. Every single time you say something new, you have to first repeat the entire conversation you've had up to that point, right from the beginning.
Wow, that would be exhausting and incredibly inefficient.
That's precisely what these AIs are doing. To remember what you talked about, they literally reread and reprocess the entire chat history with every new message you send. The paper calls this a brute force approach.
And I'm guessing that gets really difficult as the conversation gets longer.
It gets exponentially more difficult. The paper highlights what's called quadratic scaling. A simple way to think of it is if your conversation doubles in length, the computer has to do 4 times the work. If it triples, it's 9 times the work. That's why it gets so slow and expensive.
So the AI isn't really remembering in the way we do. It's just rereading everything at incredible speed. So what is this reactive transformer, this RxT, and how does it fix this?
RxT flips the whole concept on its head. Instead of treating the conversation as one giant, ever-growing text document, it treats each turn, your message and the AI's response, as a discrete event. And most importantly, it gives the AI a dedicated built-in short-term memory.
A real memory, not just a giant transcript. So how does it use this memory?
This is the really elegant part. The process is split into 2 phases. The first phase is what you, the user, experience. You send your message. The RxT quickly looks at its current memory state, figures out the context, and generates a response for you almost instantly.
Okay, that sounds great. What's the second phase? Is that the catch?
Not a catch, but a trick. The second phase happens asynchronously in the background. That means after the response has already been sent to you, the model takes your message and its own answer, processes that event, and uses it to update its short-term memory.
Ah, I see. So the heavy lifting of updating its memory doesn't happen while you're waiting for a reply. It's like a chef who serves you your meal the moment it's ready, and only then turns around to clean the workstation, instead of making you wait while they clean.
Perfect analogy. That's what asynchronous means here, and it's the key to making the AI feel incredibly fast and responsive, no matter how long the conversation gets. The user-perceived latency, or wait time, stays low.
So what does this short-term memory actually look like? Is it just a list of key facts?
It's more abstract than that. It's not a text file of the conversation. It's described as a collection of fixed-size, learnable vectors, or memory slots. Think of it less like a transcript and more like the AI's internal gist, or understanding of the conversation. The key concepts, the relationships, the emotional tone, all compressed into a mathematical format it can work with.
So it has different parts that do different jobs, like one part to talk, one part to remember?
Exactly. There's the generator decoder, which is the part that writes the actual response you see. It reads from the memory. Then there's a memory encoder, whose only job is to take the last conversational turn and create a neat, condensed summary of it. Finally, a memory attention network intelligently merges that new summary into the existing memory, updating the AI's understanding.
It's like a division of labor for the AI's brain. Okay, this all sounds fantastic in theory, but does it actually work in practice? Did they test it?
They did. They built several versions of the RxT model and pitted them against a standard, stateless LLM of a comparable size. The results were pretty dramatic.
Give me the highlights.
First, conversational quality. Even the smallest RxT model, which had about half the parameters of the baseline model, was significantly better at maintaining a coherent, context-aware conversation. It just understood the flow of dialogue better.
So smarter even while being smaller. That's a good start. What about the speed, the latency?
This is where it really shines. They ran a test where they had a conversation that was 8 turns long. The standard stateless model got progressively slower with each turn. Its response time nearly tripled from the first message to the last.
And the RxT?
Its response time was nearly a flat line. It was just as fast on the 8th message as it was on the first. The latency stayed constant because it was only ever processing the current message and its fixed size memory, not the entire growing history.
That is a game changer. It means you could have a conversation that lasts for hours and the AI would be just as quick and responsive at the end as it was at the beginning.
Precisely. And the cost implications are huge too. Instead of the cost growing quadratically, it grows linearly. Double the conversation length, you only double the cost, not quadruple it. This makes truly long-form AI conversations economically viable.
The paper really presents this as a major shift, not just an improvement, but a whole new way of thinking about conversational AI.
It calls it a fundamental paradigm shift, moving away from just scaling up these giant stateless models and instead building architectures that are intelligently designed for the task at hand. For conversation, that means having a state, having a memory.
It feels more natural, too. It's closer to how we think. We don't replay every conversation in our head from the start just to remember what we were talking about 10 minutes ago. We have a running, updating state of awareness.
That's the ultimate goal, to create an AI that feels less like a tool you're constantly feeding information to and more like a true conversation partner that shares a context with you. The Reactive Transformer seems like a huge and very practical step in that direction.
So a faster, cheaper, and smarter AI that can actually remember what you're talking about. Sounds like the future of conversation. That's all the time we have for today. Thanks for tuning in to Daily Papers.